Evening, sir.
Yes, good evening, Visos. ये लास्ट डे हमने टॉपिक केमिकल काइनेटिक्स में कहाँ तक डिस्कस किया था?
वो कर लिया था ऑर्डर ऑफ द रिएक्शन तक. व्हाट इज रेट लो, हाउ टू एक्सप्लेन रेट लो इक्वेशन.
0, 1, 2, 3 ये डिस्कस हुए थे कि ओनली मोलिकुलरिटी ऑर्डर ऑफ डिफरेंस डिस्कस हुआ था?
ये नहीं हुए थे सर. 0, 1, 2, 3 नहीं हुए.
यस, तो तभी हम ये डिस्कस करते हैं. फर्स्ट ऑफ ऑल
यस.
जीरो ऑर्डर ऑफ रिएक्शंस. यस, बेसिक. व्हाट द एप्लीकेशन ऑफ जीरो ऑर्डर ऑफ रिएक्शन? एक्सप्लेन. व्हाइट बोर्ड है आपके पास?
यस सर.
व्हाइट बोर्ड है?
A4 सीट है सर.
ठीक है. यस, उस पर एक्सप्लेन कीजिए. यस, यस,
यस.
डेरिवेटिव. यस.
So, zero order reactions are those reactions in which the rate of the equation doesn't depend on any of the reactant. For example, let us say there is a reaction, reactant A gives product B. So the rate of the equation dA upon dt doesn't depend on the concentration of the A. Yes, sir. So
Yes.
yes,
What
sir.
the
So
graph of zero order of reactions? Rate versus concentration, concentration versus time.
okay, sir. Then sir, this is on integrating. So this is the A is equal to A naught minus KT. So this is the integrating form of equation for zero order. Now, so if we plot the graph between A and T, it will be a straight line graph with slope is equal to minus K and intercept will be A naught, initial concentration of the reactant.
Yes, this one is concentration and time.
Yes, sir. Concentration and time.
Rate versus concentration.
Okay. Rate versus concentration.
Yes.
So rate and concentration. So this it will be a straight line graph, sir. So the rate doesn't depend on the concentration of the reactant. I think it will be like this, sir.
Yes, right. Yes, what the half-life of zero order of reaction?
Sir, half-life is the time period at which the concentration of the reactant becomes half of its initial value. So if the concentration as the integrated form is A is equal to A naught minus KT, so at T is equal to T half, A will be A naught by 2. So A naught by 2 is A naught minus KT half, and T half will be A naught upon 2K.
Yes, what the example of reaction of zero order of reaction?
Example. So, sir, at this moment, I cannot recall any example.
Yes, ever process. Any mostly catalyst reaction is through zero order of reaction. Yes, now like ever process is a reaction. Yes.
Okay, sir.
Next is any drawback and limitation of zero order of reaction.
Sir, drawback is one drawback of zero order reaction is that it doesn't depend on the concentration of the reactant. So the concentration of the reactant doesn't give any information about the rate of the reaction.
Yes. Good. Next, move on. First order of reaction. What the main application of first order of reaction? Yes, derivation.
Yes, sir. So first order reaction is that type of reaction in which the rate of the reaction depends only on the reactant. If we, for example, so let us say there is a reaction.
Yes, carry on. Derivation of first order.
Yes, sir.
Explain.
Yes.
Derivation and slope.
So yes, sir. So let us consider the reaction in which the reactant A gives us product P. So according to first order reaction, the rate of the equation is directly proportional to the concentration of the reactant. So minus dA upon A will be equal to K dt on integrating minus dA upon concentration of A from initial concentration A naught to final concentration A will be equal to at K dt from time t is equal to 0 to t is equal to t. So minus ln A naught to A will be kt 0 to t minus ln A upon A naught will be kt, or we can say that ln A naught upon A is equal to kt. A naught upon A is equal to e raised to the power kt. A naught is equal to A e की power kt, or A is equal to A naught e raised to the power minus kt. And so if we plot the graph between concentration and time, so from here we can say that ln A will be equal to ln A naught minus kt. So ln A versus t graph will be a straight line with slope is equal to minus k and intercept is equal to ln A naught.
Yes. log versus concentration, and concentration versus time. What will be the slope?
Only concentration versus time.
Yes.
So it will be A T. The graph will be like this, sir. Exponential curve.
Yes. Good. What the half-life of first order reaction?
Yes, sir. So as ln A is equal to ln A naught minus KT. So ln A naught by half is equal to ln A naught minus KT half. Ln, so KT half will be ln A naught minus ln A naught by 2. KT half will be equal to ln A naught by 2. So KT half will be equal to ln 2. T half will be equal to ln 2 upon K, or 0.693 upon K.
Yes. Good. And what is half-life?
Yes.
When simple words used in what is half-life? The meaning of half-life in chemical kinetics.
Half-life is that time at which the concentration of the reactant is half of the initial concentration of the reactant. Like, sir, if at initial time, we can say if at time t is equal to 0, concentration is A naught, then at t is equal to t half, that is half life period, the concentration of the reactant will be A naught by 2, that is half of the initial concentration.
Yes, good. What the reaction of first order of reaction? Example of reaction of first order.
Example, sorry sir, I don't know any example of first order reaction.
Yes, decomposition of N2O5, yeah, decomposition of SO2Cl2. All SN1 reaction is first order of reaction. Yes, no?
Decomposition of N2O5 and what is the
Decomposition of
other?
decomposition of SO2Cl2.
SO2Cl2. Okay, sir.
SN1.
S
SN1 reaction, SN1 organic chemistry.
reaction. Yes, sir. Yes, sir.
Yes. Next, move on. Next question is, what the relation between first order of reaction and radioactive decay?
Sir, first order reaction and radioactive decay.
Yes.
So, sir, in radioactive decay, the concentration, actually, what is, sir, all the radioactive reactions are of first order. So this is the relation, sir. All the radioactive reactions are of the first order reaction. So the kinetics of the first order reaction will be followed by the radioactive reactions.
Yes. Yeah, next move on. Second order of reaction. What the main application of second order of reaction? What the derivation of second order of reaction in chemical kinetics? Explain.
Yes, sir. So second order reaction is that type of reaction in which the either we have two reactants whose order uh, either we have two reactants and the order of each reactant is 1, or we have a single reactant whose order is 2. So both of these kind of reactions are examples of second order reactions. And if we write the rate equation in such type of reactions, then we have is the minus dA upon dt will depend on the concentration of the reactant raised to the power 2. So minus dA upon a square will be equal to k dt. On integrating, minus dA upon a square k dt a naught to a 0 to t. So it will be minus 1 upon a naught to a will be equal to kt. So 1 upon a will be equal to 1 upon a naught plus kt.
Yes, good. What the slope of second order of reaction is rate versus time in concentration versus time? Can you draw?
So if we draw a graph like this, slope will be equal to k, intercept will be equal to 1 upon a naught. If the graph is between 1 by a and time, and if the graph is between
Yes. Rate versus
yes,
time, concentration versus time.
so rate equal to minus d upon dt k a square so this graph will be sorry sir, I'm not able to plot this graph of rate versus time.
Okay, no problem. You look them and you have to study. Next is what the example of second order of reaction?
Sir, second order type of reactions are I think mainly used in the polymer chemistry, and any specific example I am not able to recall at this moment, sir.
SN2 reaction, all SN2 reaction is second order reaction.
Yes, sir.
2O3 is equal to 3O2. Second order of reaction.
Okay, sir.
Is what the half-life of second order of reaction?
So half-life will be as 1 upon a is equal to 1 upon a naught plus kt. So 2 upon a naught plus KT half 1 upon A naught is equal to KT half, and T half will be equal to 1 over KA naught.
Yes. Next, yes, any drawback and limitation of zero order, first order, second order?
Sir, the limitation of zero order reaction is that on changing the concentration of the reactant, we cannot change the we cannot change the rate of the reaction. So this one is the limitation of zero order reaction, and uh, I'll study about the limitations of the first and second order reaction.
Yes. Let's move on third order of reaction. What is third order of reaction? What the main application of third order of reaction? Chemical kinetics. What the derivation?
Yes. Sir, third order of reaction is like this. If 3A gives me P, so equal to, if the rate of the reaction depends on the concentration of the reactant raised to the power 3, so minus dA over A cube K dt minus 1 upon A square, 1 upon A square minus 1 upon A naught square will be K dt on integrating from A naught to A 0 to T. So 1 upon A square will be 1 upon A naught square plus KT. So this is the derivation of the third order reaction, sir.
Yes. What the graph and slope of third order of reaction? Rate versus concentration and concentration versus time.
We plot the graph between concentration and time. It will be a straight line graph with slope k and intercept 1 upon A naught square, and the graph between rate and concentration. I think so. It will be a decreasing graph with increasing slope. So it will be like this: R versus A. And the other graph is like this: 1 upon A square versus T, straight line graph.
Yes. What is the half-life of zero order, third order of reaction?
Yes, sir. So as 1 upon a square is equal to 1 upon a naught square plus kt 4 upon kt half 3 upon a naught square kt half. So t half will be 3 upon ka naught square.
Yes, good. Any example of third order of reaction?
No, sir, I haven't studied about the examples of any of the reactions.
2NO plus O2, 2NO2. 2NO plus Cl2, 2NOCl. 2NOBr2, 2NOBr.
What was the first example, sir? 2NO plus O2?
Yes, 2NO2.
Okay.
2NOBr2, 2NOBr.
Okay.
Any limitation and drawback of third order of reaction?
Sorry, sir, I don't know any limitations or drawback of third order reaction.
Okay, no problem. You look them. You have to study.
Yes.
Next is
about it.
yes. Next is what the difference between pseudo order of reaction and first order of reaction? What the difference?
Sir, the major difference is that in zero order reaction, the rate of the reaction doesn't depend on the concentration of the reactant. But in first order reaction, the rate of the reaction depends on the concentration of the reactant. So this is the major difference between zero order reaction and first order reaction, sir.
Pseudo order. Yes, I am talking about the pseudo order and first order reaction.
Yes, pseudo order.
Yes.
So, sir, I heard that zero order reaction and first order reaction. So pseudo order reaction is like this, sir. If we have a reaction of second order, A plus B gives me the product. But if I take the reactant A in excess or reactant B in excess, that is the concentration of A is much higher than the concentration of B. In such case, sir, the rate of reactant depends only on the concentration of B. So such type of reactions which are not actually of first order, but under certain circumstances behaves like the reaction of first order. So such type of reactions are known as pseudo first order reactions. That is the reactions which are actually not of first order, but under certain circumstances behaves like the reaction of first order.
Yes. Good. Any example of pseudo order of reaction?
No, sir.
CH3COO CH3 plus H2O CH3COOH acid.
CH3COO CH3 plus
H2O.
H2O.
Yes.
Okay, sir.
Presence of H plus ions.
In presence of H plus ions.
The product at CH3COOH plus CH3OH.
CH3OH.
CH3COOH. Yes. Plus CH3OH.
Yes, sir.
The next move on. Next new topic is activation energy.
Oh, sorry, sir.
What is activation energy? What is the basic principle of activation energy?
Yes, sir. So activation, if we have any reactant which needs to be converted to product, then a certain minimum energy is required, and that amount of energy or that particular energy is known as the activation energy. Next, sir, if we have a reactant here and I need to convert it to product, so this particular amount of energy which is needed to be supplied to the reactant so that it converts into product, this amount of energy is known as the activation energy.
Yes. What is threshold energy?
Sir, I think activation energy is the minimum threshold energy which is required to convert the reactant to product. The minimum amount of energy is the threshold energy, and the any other energy which is greater than the threshold energy or equal to the threshold energy is activation energy.
Yes. What is the difference between actual energy, activation energy, threshold energy? What is the difference?
Sir, actual energy is the energy of the constituent particles of the reactant, or we can say that the energy of the reactant. For example, if the y-axis here shows the energy, then this particular energy is the energy of the reactant or its constituent particles. It is its actual energy. Threshold energy is the minimum energy which I have to supply to the reactant so that it convert it so that its molecules collide with each other, uh, leading to the formation of the product. So the minimum energy is the threshold energy, and the energy which converts the reactant to product, or any energy which is higher than this minimum amount of energy, is the activation energy.
Yes. What is the difference between exothermic and endothermic reaction?
Yes, sir. So endothermic reactions are those type of reactions to which energy is required to be supplied. For example, to convert the reactant R to product P, if we have to supply any energy or heat to reactant R, such type of reactions are endothermic reactions. And if on converting reactant R to product P, heat is released, heat or energy is released, then such type of reactions are exothermic reactions. That is, if heat energy is supplied to the reactant, that reaction will be endothermic reaction, and if on converting the reactant to the product there is a release of the energy or release of heat, such type of reactions are exothermic reactions.
Yes. Any drawback and limitation of activation energy?
Drawback. I think, sir, one drawback can be that activation energy can be calculated only experimentally. As I haven't studied any theoretical model which can predict activation energy. So this can be one drawback, sir.
Yes. Your next move on Arrhenius equation. What is Arrhenius equation? What the main application of Arrhenius equation?
Yes, sir. So Arrhenius equation gives us the relation between the rate constant and temperature. So Arrhenius was the first scientist which predicted the relation, which gives us the relation between the rate constant and the temperature. So Arrhenius equation is log K2 by K1 EA by R T2 minus T1 upon T1 T2. So this is the integrated form of Arrhenius equation, which gives us the relation between the rate constant, activation energy, and temperature. From this equation we can predict that how much will be the rate constant will be changed on changing the temperature from T1 to T2. And the differential form will be d by dt of ln k E upon RT square.
Yes. Yes. How to determine the activation energy from Arrhenius equation?
Sir, for example, if we have any reactant R2 product P, what we can do, sir, is that at temperature T1 we can calculate its rate constant. Then on changing the temperature to T2 we get another rate constant which is let us say K2. So using these two temperatures and these two rate constants, and on putting them in the Arrhenius equation we can calculate the value of the activation energy.
Yes. Yes, good. What is integrated Arrhenius equation? What the formula and how to drive it?
Sir, this is the formula. Log K2 by K1 is equal to EA upon 2.303 R T2 minus T1 upon T1 T2.